going to do some like quote-unquote live coding. I was going to show you the terminals. This might get a little sketchy, everybody. Just be really supportive, okay? That's the key thing. Cool, so my name is Celeste Horgan. I am a senior developer advocate for open source at Snowflake. What senior developer advocate means is that I come and I give a lot of talks at conferences and stuff, and I create technical content. What that means for me in specific is I actually spend about half of my time doing upstream contributions to projects like Apache Spark. But I also spend a decent chunk of my time facing internally and running Snowflake's open source programs office and making sure that we don't get sued when we decide to open source things. So that's not what this talk is about, but I do love talking about open source programs offices, so if you want to have that chat, come find me after. This talk is about building Apache Spark pipelines, specifically to detect raccoons. Okay, this is a slide that Snowflake makes me display. As you can see, it's a very interesting slide, and I'm sure you're all going to read it in a huge amount of detail. Yay, we saw the slide! Okay, so, who here knows what Apache Spark is? Or has used it? Okay, so about half. This is really intended as like an introductory talk for Spark when I give it, so like for you guys, like just please, again, be nice to me. The next thing we're going to talk about is what Spark is really, really good at. We're going to build a bit of a data pipeline, and then we're going to have a question mark, profit sort of moment towards the end. Yeah, let's rock and roll. So, Apache Spark is like a really hard project to understand. Even if you've encountered it in production, I think it's really easy to misunderstand what the project is, and certainly when I started getting involved upstream on Snowflake's behalf, it took me a while to grok what this thing was. And the best description I have, and the entire reason that this entire talk is Raccoon themed for no good reason, is that it's like kind of a bunch of raccoons in like a trench coat. It's really a bunch of like functionality that is kind of distinct both in its implementation and its use cases that are unified by kind of this Spark runtime layer. And the entire purpose that Spark exists is to allow you to do data pipeline things. So you're typically never deploying Spark on its own. You're feeding data from something, you're doing something, and you're feeding it away. So, what are the raccoons in the trench coat? We've got kind of large-scale extract, transform, and load pipelines. This is a lot of what you see Spark in production for these days. Spark is typically deployed as a cluster, so it's not really like a single node thing, and it is typically used for really, really large-scale data transformation. The reason it's like such a sticky piece of software is because that cluster architecture makes it very, very stable to run these kinds of workloads, and so it's the kind of thing where it's like once it's deployed, it's like really hard to get rid of. So, you know, we'll talk about this later in the talk, but like, it's very, very common that you deploy Spark, but I don't know that you would want to deploy Spark necessarily in 2026. It's more just like you're going to encounter it, so it's good to know a little about it. And it's usually for large-scale ETL stuff. Another sort of branch of the weird Spark world is this entire functionality called MLlib. It does inference and other sort of classical machine learning algorithm processing. It doesn't do like inference or generative AI, so it's, I hate to say it, it's probably a little bit out of date now, but if you are doing more classical machine learning like functionality, it's definitely an option, and especially if you've already got a Spark cluster running, you may as well evaluate it. Another thing it does is near real-time stream processing, which sounds really weird, and you're probably thinking, but why don't I use Apache Kafka? And you totally could. It's again, it's the kind of thing where it's like if you've got a Spark cluster running, you could probably consider it. It also does sort of SQL-based data analysis, so you can kind of perform joins and like perform like lookups and stuff like that. It also does graph processing and a whole bunch of other things. So it really is like, I always like to think of it as kind of the transform layer superhero. It is very much a Swiss Army knife of a project. I would say the core of its functionality is really just churning through huge data sets or doing like transforms and loads on like really, really large amounts of data. But it can do enough things that it has a sort of like stickiness to it once it's in deployment. And in comparison to a lot of other data pipeline tools, the thing that comes to mind, especially with Splink actually, it is very, very robust and very, very stable, which makes it really suited for big data in production. That said, it does kind of suck, and I think it is really important to talk about the ways in which projects suck and why you might not want to choose them. So the thing with Spark is, I think it was donated to the ASF in like 2012 or something like this, so it's starting to show its age. It's like a big, heavy JVM-based thing, so it's not like a light deploy. It's, you know, MLlib at this point is maybe like not the best library for doing machine learning related stuff. There's like way better options, especially in 2026. And I think this particular crowd knows a thing or two about those options. It was really built to kind of pair with Hadoop and MapReduce. Like the ASF, when they accept projects, really like to accept projects that play nicely with the rest of the ecosystem. If you read through the documentation in detail, and it's an open source project, so things don't always get updated that quickly, it's still talking about Hadoop and MapReduce, which again, I would say that neither of those are maybe the correct infrastructure choice in 2026 for doing data and analytics, so we'll certainly encounter them. So it's a bit hard to sort of like translate those concepts into things you might want to do in 2026, and I think that just is part and parcel of this ecosystem. But the chances that you're going to encounter Spark at some point in your career as a developer are super high, regardless. Okay, I would say the key thing to understand about Spark, though, is it's an intermediary step. It is a data processing step. It is not like a place where data lands. It's not a place where you would want to store data long term. It's a pipe to move through. So speaking of pipes, let's build a pipeline, as indicated by the raccoons in the pipe. Thank you very much. So what are we doing? I am very poor at inspiration at the best of times, so I decided that our pipeline should detect images of raccoons within a larger data set of images of animals. So I'm going to send this to an Apache Kafka topic, again, just to really like drive home the point that like you want the data to go elsewhere. You don't necessarily have to send it to Kafka, it's just like the thing that came to mind when I was building this. So really what we need to kind of get ourselves started is we need a large image data set. We need to do visual inference against it, so we need a model that we can then sort of train and work with. And then we need to analyze the data set for raccoons. I need to hit my foot. Okay, so you may be sitting here thinking, Celeste, why raccoons? No real reason other than I made the very first slide of this presentation first, and that image of like the raccoons in the trench coat just sort of stuck with me as I was like building out this presentation. They're evil. With their cute cat-like ears. How many of you have met a raccoon in person? Sorry, this is Europe. I forget that it's Europe sometimes. So raccoons are very, very common in North America. I'm from British Columbia, Canada, which is where Vancouver is. It's just north of Seattle. They're about as common there as foxes are here. So you see them all the time, and they cause all sorts of raccoon-shaped problems. In Vancouver, they're affectionately known as trash pandas because they like to eat trash. So that's my relationship with them. They do look adorable like little bandits, but like they will rifle through your trash. They're wearing burglar masks, evil, and they dig through your trash, also evil. So we should probably filter out the raccoons because we have to assume that here in Europe, they are invasive. Okay, so this is where I'm going to attempt to do a little bit of coding directly in front of you, and again, you're all going to be very supportive. I usually say this in my talks, but I didn't get around to it this time. I actually began life as a technical writer, so I was doing software documentation for many, many years, which is why you're going to be extra supportive. of my attempt to do code, okay? Okay, what I'm actually going to do, and sorry, I'm just setting this up on my laptop, is I'm going to walk you through the pipeline, and then we're going to actually run the pipeline. I will say that the model is pre-trained because the data set that we're working with is like 60,000 images across 3 Horgan files, but I'm like not going to do that to you. Because that will take like 3 hours, and also Hugging Face doesn't want to talk to me right now for various token-related reasons. So this is how we're doing it, everybody. Okay. Do I want to try and mirror the display? No, that doesn't seem to be working. Okay. We're here. See, the problem is now I have to like talk at the screen, and also remember how to get the cursor over. Okay. So, I whacked it. Oh yes. So I don't. Okay, we're gonna do it this way, everybody. So, very quickly, there's some boring stuff up front. We're gonna use PySpark as our Spark implementation of choice. This is because I know Python best. The other thing we're using is obviously this sort of Kafka library to build just like a local Kafka cluster. Kafka, for those of you who don't know, is a stream processing tool. So if you want to like plop data into a Kafka topic as you go, that is the thing that you can do. So we're going to use PyTorch to train the model. Like I said, the model is already pre-trained because I'm not interested in doing that to you live. That would take like an hour or two. The other thing that we're going to use is the Hugging Face transformer for visual inference. And before I go on, let's go back here for a second. This is what PySpark is. We just discussed it. The one thing that I would note about the Spark packages, if you do have to implement Spark, the different language packages implement Spark in different ways. And there are some pieces of functionality that aren't available, say, in the Scala package, notably data frames, that are available in PySpark. So it is like something to keep in mind, is that your experience of Spark may not be the same from package to package. Speaking of which, we're not going to talk about a data frame just yet. We will talk about an Apache Parquet file. So who here knows what an Apache Parquet file is? Okay, we got one. So Apache Parquet is a way of storing large data sets, particularly data sets that have been like annotated or otherwise structured, and sort of compressing them for typically storage on like an S3 bucket. So now let's see if the demo gods love me. Ooh. Okay, those are my notes. We're going to pretend you didn't see them. What do I want to see? What do I want to see? I want to see my folder structure. I have opened the folder. Why are you doing this to me? Open. Rude. So I'm just going to kind of show you the data set. So, what am I looking for? I am not going to open these. So our data set is a set of about 60,000 images of various animals. This was found on Hugging Face. It's stored across 3 Parquet files, and I want to say it's about 12 gigabytes of data. Ironically, the original data set does not have any raccoons in it, so it is a European data set. So something that we have to do in our pipeline is populate the data set with raccoons so that we can then detect the raccoons, which is hilarious, but we're going with it. So we also specifically have a data set of raccoons. Kicking around here, this is just a separate data set of raccoon images, and also where all the images, all these slides have come from. So, going back to make.py, if I can find it. Normally you would want to be like more organized about this, but this is just for the purposes of talking about Spark. The first thing we're going to do is we need to sort of pre-train our model. We're going to use Hugging Face's VIT transformer to do that. It is a visual inference transformer, as you may have sort of gleaned. And what that's going to do is do a couple of things. One, it's going to read through our very, very large data set to know that it's looking at images of animals. The second thing it's going to do is it's going to insert about 10 raccoon images into that data set so that we have some raccoons to detect. And the third thing it's going to do is it's going to look at our data set of about 200 raccoons to train itself on like, what we're looking for. So that's what's happening through all of here. And like I said, this takes a really long time. And I was trying to train this model again for no apparent reason other than I wanted it to be fresh for you all, but Hugging Face does not want to talk to me tonight. So the thing we're actually most interested in terms of our like learning a bit of Spark is how Spark processes data. The nice thing about Spark and why it's so used for so many kind of like ETL pipelines is it processes data in parallel really, really easily. And it uses, I believe we're using pandas for this. Pandas is a batch processing, yes we are. Pandas is a batch processing pipeline. It allows you to do things in parallel, which when we're working with large data sets means that things go faster. So the next thing we're going to do is use Spark to kind of process through the inference and to do that in parallel for us. Which is really, really nice, and one of the great things that Spark can do for us. And then the final thing we're going to do is we're actually going to run the detection and say, please find me some raccoons. And when you find some raccoons, please publish them into a Kafka topic so that we have a run of our raccoons. So let's wish me luck. What's going on here? So, this is our Kafka topic. You don't need to worry about her. She's just kind of doing her job. The thing we are going to worry about is going to be on this other terminal that is very poorly correct. So, we're going to run python main.py. We're going to skip training because we've already trained the model. That takes like forever. And we're actually only going to use a sample of 500 images because I don't want this to run forever. And hopefully, if I hit enter, everything will go correctly. But for now, we'll let that go on in the background. Where's my mouse? So, a few things to note about Spark, because again, we're here to learn Spark. Spark uses the concept of data frames to organize how things come into Spark and how things leave Spark. So typically when you load a bunch of data into Spark, it wants you to assemble them into a thing called a data frame. A data frame is basically like a temporary table, so if you're familiar with Flink, Flink does a very similar concept. It's also very similar to, this is only relevant to Snowflake customers, like materialized views. With very few exceptions, you're going to use the concept of a data frame a lot if you ever do get into Spark. What else do I have slides on here? We talked about Apache Parquet. Columnar file store, it allows you to store data and access it very, very quickly if you're dealing with really, really big data sets. So if you're involved in like Apache Iceberg conversations in your life at all, like apologies, but also you're probably very familiar with Parquet for similar reasons. What else? Pandas. So I mentioned that we were using Pandas to do kind of parallel processing. Pandas is a Python data analysis library. It has really, really strong support. With Spark, they're very often paired. I would sort of say the biggest downfall of this is that Spark is in the JVM, Pandas is Python-based, and so if you're doing stuff, you're moving things in and out of the JVM, that just like takes a bunch of time. We're not using AMOLib for hash tag reasons, but I think we already discussed this, so I'm going to go over this really quickly. This was for a meetup for Confluent. I didn't update the slide. You already know what Kafka is. But let's look at our little pipeline before we move on. Ooh, come back to me. So, our pipeline is run, and it has detected 10 raccoons, which is lovely. But I'll tell you right away, they're not necessarily the most trustworthy results. So for example, you'll notice that we've detected a Pomeranian, a cat, a chicken, a bunch of raccoons, which we expected, a Maltese dog, a toy poodle, and then a bunch more raccoons. But this is basically what the output looks like. And we were able to do this much, much faster than we would have if we weren't using Spark, because again, Spark is really, really good at helping us move through data really quickly. And when you're working with machine learning or AI, you're typically moving through a lot of data really, really quickly, particularly if you're in the model training phase. Okay. Wrapping it up. An inconvenient raccoon truth. I used an L1 for this code because, as I mentioned, I started my life as a technical writer. And as some of us were discussing over the break, a lot of using L1s or using generative AI is really being able to break down a problem such that a computer can understand it. And fundamentally, these tools are still computers, and they still think about problems in computer-shaped ways. I was able to get to the output that I wanted, that was valid and decent code, because I had 10 years under the hood of being a technical writer, describing code, and having to think about code in a linear fashion that is explainable to other people. But I do think it's a really, really important thing to note, especially as we kind of move forward into this new kind of vibe coding life. What does it mean for technologies like Spark, which are really a lot of people's bread and butter from an employment perspective? And what does it mean to be a coder in all of that? This is my working group, but I don't think this is exciting to this particular crowd. I did ask the LLM if there was anything we could have done differently, and I think this is another important conversation, specifically to have about Apache Spark in 2026. As I've mentioned a few times throughout the duration of this talk, it is a pretty heavy install. You're typically deploying it as a cluster. It is JVM based. It's relatively just resource intensive. It's not necessarily cloud native, so you can deploy it to Kubernetes. It can play alongside your cloud native technologies, but that's not its mental model of the world. And I think the important thing to think about Spark is for everything that Spark does, and all of those raccoons in a trench code, there's probably an alternative that is more lightweight and more modular that you could use today if you wanted to. And I think that's just an important thing to know. You're going to encounter Spark in your life and your careers because it is in deployment in so many different places. It's not necessarily the choice you would make doing something from scratch in 2026, in my opinion. We could have done some more stuff. That's all I got for you. But yeah, thank you very much.
Questions for Celeste?
Are you muted? I am. Yeah. Sorry, I didn't have a QR code. Yeah. Thank you all for your time.